Lesson 2, we're looking at analyzing reflections. So we're talking about how does a reflection affect the properties of a two-dimensional figure. When you hear the word reflection, you might think of maybe a mirror. You look at your reflection in the mirror, and so what's happening when you look at your reflection is everything gets flipped around. If something looks like it's on the left, it's really on the right, for example. So reflection flips a figure over a line of reflection. And again, another way of thinking about reflection is like a mirror image. So if you think about if you flip something over, does its size change? No. It's still the same size just because we flipped it over. Okay? Things might look a little bit different, but it's still going to be the same size anyway. So when we do a reflection, we have a line of reflection is just a line over which the figure is reflected. And what's going to happen is however far we were away from the line of reflection before, when we flip over that line of reflection, we're still going to be the same distance away from the line of reflection. In other words, if this was 10 feet here, if we reflect it across the line of symmetry, they sometimes call it, or the line of reflection, I guess, it's going to still be 10 feet away. So you can see what they did on example 1. They're flipping the placement of the grill to put it on the other side of the patio. Look at example 2. Polygon ABCDE has these vertices. Graph and label the vertices after reflection across the x-axis. So x-axis is our horizontal axis, goes across. So what we want to do is think about each of these points. Originally we've got this whole thing is above the x-axis, and we're going to go below the x-axis. So if you look at point A, for example, point A is 2 units above the x-axis. When we flip it, it's going to now be 2 units below the x-axis. B started out 4 units above. Now it's going to go 4 units below. Another way you could look at that is it's 2 units above B. Now it's going to be 2 units, 2 units above A. Now it's going to be 2 units below A. Okay, we're just doing that for each of these points. You know, E, for example, was 2 above is 2 below. C was 5 above, goes 5 below. D was 5 above, goes 5 below. And again, if you'll notice, whenever we do this, our new figure is the same size as we had initially. It's going to look a little bit different to us maybe, but it is going to keep the same size that it had to start out with. It'll have the same area. If you look at example 3, this one they've got a reflection already done here, and they want us to describe what reflection happened. Well, pretty much our reflections at this point, either we're going to reflect across the x-axis or we're going to reflect across the y-axis. So this one, if you'll notice, is being reflected across the y-axis. Okay, a way to think about this is that line of reflection, if we would fold our paper on that line of reflection, the two figures should match up exactly. You see that? Okay, so this is just a reflection across the y-axis for this one. We can do, I don't know that we've done this type of thing before. This is another possibility. On the try it, we have a polygon that's reflected across the line x equals -2. And they want us to graph that new image. So x equals -2. Think about some points where x is -2. Well, -2, 0, -2, 1, -2, 2. Those are all points where x is -2. So this actually, x equals -2, is a vertical line here. And it might seem counterintuitive here. We might think, x equals something. X, we're thinking normally horizontal, but all the points where x equals -2 is going to be on this vertical line. So if we draw that line, now we can look and see how far our points are away from the line. So A, you can look, is 2 units to the left of that line. When we reflect it, it's going to be 2 units to the right. B starts out 1 unit to the left. It's going to go 1 unit to the right. C is 1 to the left, would go 1 to the right. D is what? 3 to the left is going to go 3 to the right. Make sure you put your primes on these. And E is 3 to the left is going to go 3 to the right as well. Okay? When we draw this, when we connect these dots, the size should be the same. It's going to look a little bit different. But again, think about if you would fold on that line, these would match up with each other. And then the other question they ask after we graph that, they want to know, is the measure of angle A equal to the measure of angle A prime? So did any of the angles change? No, none of the angles changed, so for that one we would say yes. We could say yes, no angle measures changed, or something to that effect. Key concept, just recapping what we talked about here. Again, reflection across that line. If we would fold on the line, they would match up. Look at the do you know how number 4. A little different look. We got a diagonal line here, and they're asking if that's a reflection across line G. So think about line G, if it helps you to turn your book there, make it easier to see maybe. Does that look like a reflection?
Yes.
Yes. Okay, good. Yes, that is a reflection on number 4. Okay. Look at number 5. They want us to describe this reflection. So what we have to think about is, where can we draw a line where these two things would match up? Well, there's not a ton of room in between them, so maybe we can see this here.
How do we know which one's the original one?
The original one is the one with just the regular letters, and the new one is the one with the little primes, the little marks next to it. Okay, so this would be a line of reflection. Does that make sense? Right in the middle between those. Now what we have to do, we have to tell what the equation of that line is. Well, think about all the points on the line. If you have either a vertical or horizontal line, Either all your x's are going to be the same or all your y's are going to be the same. For this line, which one is all going to be the same? The y's actually are all the same. Okay? And if you're not sure, just label some points here. This is the point 0,4. This is the point 1,4. Okay, it must be my y's then. Does that make sense? So what's true about all the y values on this line? And they are all what number? 4. So my equation must be y equals 4. Good. So for number 5, when we talk about that reflection, that's a reflection across the line y equals 4. Then number 6, they want us to draw an image that would result from the reflection of the figure across the line x equals -1. So going back to what we talked about earlier, this red figure doesn't have any markings on it. It just has plain EF, GH. So I know that's my original one. We're going to reflect across the line x equals -1. So just take any point that has x equals -1. So if you want to start out here, -1, 0, -1, 1, -1, 2 if you want. Okay? Get a few points to make sure we're graphing this right. X equals -1 should be like this. A vertical line. All the x values are -1. Okay? Then we're just going to look at each point and how far they are away from that line. Whatever order you want to do this in, if you want to start with the closest points, H is the closest point, is 1 unit away to the left, it's going to go 1 unit to the right. Now when we label that, normally we would just put that as H prime. Technically, since we already had an H prime, that blue figure up there, generally what we would do is do H double prime. We put 2 marks next to it just to distinguish that. G starts out 3 units to the left, it's going to go 3 units to the right. Or you could say it's 2 further over than what H was. Point F is 4 units away to the left, so we'll go 4 units to the right when we reflect that. And point E is 7 units away from this line x equals -1. So 1, 2, 3, 4, 5, 6, 7. And then again, if we connect these points together here, should look pretty similar to what we have on the other side. It's going to look a little different because it's flipped, but should see some similarities there. We look at workbook page 72, number 6. We have a reflection here. The question is, what reflection produces this image? In other words, what line are we reflecting across? Well, this one they're a little bit further apart, so it's a little bit tougher for us to detect that exactly. What I would suggest is maybe take your 2 closest points and see how far they are away from each other. So if you look at G to G prime, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 units apart from each other. Both of them are going to be the same distance from our line of reflection. So if that total distance is 10, how far would each of them be away from that line? 5. Good. If we just split the difference between those two, or the distance between those two, that's going to be how far away we are. Now, this doesn't mean our line is going to be necessarily like an x equals 5 or x equals negative 5. It just means we need to go 5 blocks away from either of these points. So if you go down from G, for example, 1, 2, 3, 4, 5, which you can double check, go up from G prime, 1, 2, 3, 4, 5, okay? That proves these are going to be the same distance from this line. That means our line would be right here, okay? Now, I see the negative 2 there. The question is it going to be x equals negative 2? Is it going to be y equals negative 2? Think about points on that line. Which one's it going to be? Y equals negative 2. And again, it's kind of opposite of what you might think. Normally we're thinking y is up and down, is the y-axis, but actually vertical lines are always x's are always the same, horizontal lines, the y's are always the same. So y equals negative 2 would be our line of reflection on that one. Number 8, we've got a similar setup here. This one's multiple choice, but same idea. So again, if you want to look at your points that are closest together, the B's are the closest, B and the B prime. So these 2 points are 8 units away from each other. So if we split that difference there, our line of reflection is going to be 4 units away from either of these. 1, 2, 3, 4. And again, if you want to double check from your other one. Okay, so here should be our line of reflection. And we need to just think about what equation that line would have. So this line, vertical line, actually is going to be an x equals something. All the x values on this line are going to be 1. Again, just, if you want to put some points here, just say this is the point 1, 2. This is the point 1, 3. And always one of them will be the same. Either your x's will be the same or your y's will be the same, if that helps you to come up with that. X equals 1, and so that means we want letter choice A. Good. And if you look at part B, measure of angle A is 110 degrees. What's the measure of angle A prime? Still 110 degrees. Okay? So this gives you an idea of how to analyze reflections.